Hello students, welcome to chemistry class. In the last class we have studied about how to calculate the empirical formula and molecular formula. In this class let us understand about chemical equations and stoichiometric calculations. So this is very important topic of this chapter for competitive exams, that is for JEE, NEET as well as for the Karnataka CET examinations. Let us see what are chemical equations and what are stoichiometric calculations. In that first one, that is chemical equation. So chemical equation is nothing but it is a brief representation of a chemical change in terms of symbols or formulas of the substance involved in it. That is, any chemical reaction is to be represented in terms of their symbols or formulas of the substances involved in it. For example, let us take the reaction of the silver nitrate. That is, formula for silver nitrate is AgNO3, that is silver nitrate. So this silver nitrate reacts with the sodium chloride, that is NaCl. So it is to be called as sodium chloride. Sodium chloride. So the reaction between the AgNO3 and NaCl, it gives a new product, that is Ag combines with the negative part of the NaCl. Generally Ag has positive charge, that is to be called as cation, and NO3 has negative charge, it is to be called as anion. Like that, in the NaCl, sodium is positively charged particle and Cl has negatively charged particle. So positive charge of one molecule combines with the negative charge of the another molecule, it gives, that is Ag combines with the Cl, it gives AgCl, and this Na, that is cation from the sodium chloride, is Na, that combines with the NO3, it gives NaNO3. So AgCl is to be called as silver chloride, and this NaNO3 is to be called as sodium nitrate, right? So the reaction between the silver nitrate with the sodium chloride gives silver chloride and sodium nitrate. So in this chemical reaction, the substances which react among themselves to bring about the chemical changes are known as reactants. So here the reactants are AgNO3 and NaCl. So it is to be called as reactants. So reactants are the substance which react among themselves to bring about the chemical changes. Such substances are generally to be called as reactants, whereas the substances which are produced as a result of the chemical change, that substances are generally to be called as products. They are to be called as products. That is, products are the substances which are produced as a result of the chemical change. That is, between the reaction of AgNO3 and NaCl, it produces new chemical substances. That new chemical substances are to be called as products. So these new chemical substances are to be produced because of the chemical changes of AgNO3 and NaCl. So AgNO3 and NaCl are to be called as reactants, and AgCl and AgNO3 is to be called as products. So any chemical equation, it is a brief representation of a chemical changes in terms of symbols or formulas of the substances. So the reactants and products of the chemical equation are to be separated by arrow pointed towards the products. That is, this arrow indicates the chemical changes of the reactants and the products. So let us see what are stoichiometric calculations. That is stoichiometry. So stoichiometry, the word is derived from the two Greek words. That is, stoichion is nothing but element and metron is nothing but measure. That is, in the stoichiometry, we are going to deal about the measure of the elements. And this stoichiometry deals with the calculations of masses, sometimes volumes, that is, if the chemical reaction contains gases, of the reactants and products involved in the chemical reaction. That is, this stoichiometry deals with the calculations of the masses, that is, how much amount of reactants are to be involved in the chemical reaction and how much amount of products are to be formed during the chemical reaction. That amount of masses or masses of the reactants and products are to be explained based on the stoichiometrics. So that calculations are generally to be called as stoichiometric calculations. For example, let us take one simple reaction, that is combustion of methane. That is, methane formula is CH4. So this methane has gaseous state and this methane reacts with the oxygen, that is O2 gas. So it gives the product, that is carbon combines with the oxygen, it gives carbon dioxide gas is to be eliminated, and hydrogens combines with the oxygen and it produces H2O molecules. So all the reactants and products are in the gaseous states. So the number of atoms in the reactant side must be equal to the number of atoms at the product side. That is, law of conservation of mass explains that the number of atoms at the reactant side must be equal to the number of atoms at the product side. That is, matter neither be created nor be destroyed, just it converts from one form to the another form. So methane and oxygen are generally to be called as reactants. They are to be called as reactants, and this carbon dioxide and H2O molecules are to be called as products, right? So methane and oxygen are the reactants and carbon dioxide and H2O molecules are generally to be called as products. So apply this law of mass action, that is, number of atoms at the reactant side is always equal to the number of atoms at the product side. So here there is 4 hydrogen atoms. So in order to balance the 4 hydrogen atoms, multiply water molecules with the 2. That is, 2 to the 4 hydrogen atoms. So hydrogens are balanced. And let us check number of carbon atoms. That is, at the reactant side it contains only 1 carbon. So products also contains only 1 carbon. And oxygen atoms, that is 2 to the 4. So in the product side 2 oxygen atoms are with the carbon and 2 oxygen atoms are present in the water molecule. So totally 4 oxygen atoms are to be balanced. In that, the number before the formula unit or molecules used to balance the equation is to be called as stoichiometric coefficients. That is, during the chemical reactions, so the number before the formula unit, that is, number before the formula unit means here there is no number, that indicates that it contains 1. That is, 1 methane reacts with the 2 oxygen molecules, it gives 1 carbon dioxide molecule and 2 water molecules. So this number is to be called as stoichiometric coefficient. So it is to be called as stoichiometric coefficients. So these stoichiometric coefficients are generally used to balance the number of atoms at the reactant side and at the product side. So stoichiometry, it deals with the study of the calculations of masses and sometimes volumes of the reactants and products involved in the chemical reaction. So the number before the formula unit or molecule used to balance the equation is to be called as stoichiometric coefficients. Let us consider, that is combustion of methane, that is methane formula is CH4, so that reacts with the oxygen gas, so it gives the product, that is carbon dioxide gas plus H2O gas. That is all the reactants and products are in the gaseous state. So let us see how to explain this combustion of methane reaction in the stoichiometric calculations. That means first balance the chemical reaction, that is it requires 2 moles of oxygen and it produces 2 moles of water molecules. That is 1 molecule of methane, 1 molecule of methane plus is indicated as, that is reacts with, that methane reacts with 2 molecules of what? Oxygen. So that arrow mark is to be represented as to give 1 molecule of carbon dioxide and 2 molecules of water. Or this reaction is also represented as, that is 1 mole of methane plus is written as reacts with another reactant, that is oxygen molecule. That oxygen has 2 moles, so it is to be written as 2 moles of oxygen gives 1 mole of carbon dioxide and 2 moles of water. So the reaction is to be represented in terms of moles. In the first statement, the reaction is to be represented in terms of molecules. And let us take one more time, that is mass of the reactants and products. So molecular mass of methane, that is equal to 1 into 12 plus 4 into hydrogen atomic mass is 1, that is 12 plus 4, that is equal to 16 grams per mole. So 16 grams of methane reacts with 2 into, so molecular mass of oxygen, that is oxygen 2 into 16, that is equal to 32 grams per mole, right? That is 2 into 32 grams of oxygen to give 1 mole of carbon dioxide. So 1 mole of carbon dioxide means, that is molecular mass of carbon dioxide, so carbon plus 2 into atomic mass of oxygen, that is equal to 12 plus 2 into 16, that is equal to 44 grams per mole. So molecular mass of carbon dioxide is 44. so it gives only 1 mole, so that is 44 grams of carbon dioxide, and it gives 2 moles of water. So 2 into molecular mass of water is 18 grams. So 2 into 18 grams of water. Or it is also to be represented as, that is, this chemical reaction is to be represented in terms of volumes, because all the reactants and products are in the gaseous state. That is 1 mole of methane. So according to Avogadro's law, equal volume of all gases contains same number of molecules. So at standard temperature and pressure, 1 mole of any gas occupies 22.7 liters. That is 22.7 liters of methane. 22.7 liters of methane reacts with 2 into 22.7 liters of oxygen to give, so 1 mole of carbon dioxide occupies 22.7 liters of carbon dioxide, and 2 into 22.7 liters of water at STP. So at standard temperature and pressure, so 1 mole of methane gas occupies 22.7 liters by volume, and 2 moles of oxygen occupies 2 into 22.7 liters of oxygen by volume, and it gives 1 mole of carbon dioxide. So 1 mole of carbon dioxide occupies 22.7 liters, and 2 moles of water molecule occupies 2 into 22.7 liters of water. So this is to be called as stoichiometric calculations. That is, how much amount of reactant reacts with the another reactant. So it gives how much amount of products. So masses of the reactants and products involved in the chemical reactions are to be explained based on the stoichiometric calculations. So stoichiometric calculations or stoichiometry deals with the masses and volumes of the reactants and products involved in the chemical equations. So in the first equation, that is, chemical reaction is to be represented in terms of molecules, and in the second one, the chemical reactants, that is reactants and products, are to be represented in terms of moles, and third one, the reactants and products are to be expressed in terms of molecular mass. That is, amount of reactants and products are to be expressed in the grams. And if the chemical reaction contains gaseous reactants and gaseous products, in that time the volume of the reactants are to be expressed. So any chemical reaction can be explained based on the number of moles, number of molecules and masses of the reactants and products, and if all the reactants and products are in the gaseous state, that is to be expressed in terms of volumes. So this is to be called as stoichiometric calculations. So very important and simple concept. First we have to write the balanced chemical reaction. So after writing the balanced chemical reaction, then express it into required method, that is either to the number of moles, number of molecules, or mass or volumes. So in order to produce 44 grams of carbon dioxide, it requires 64 grams of oxygen and 16 grams of methane, right? So in order to produce 44 grams of carbon dioxide, 44 grams of carbon dioxide. It requires 16 grams of methane and 64 grams of oxygen, right? So during the chemical reaction, that is, for example, let us take the same reaction, that is methane reacts with the 2 moles of oxygen. It gives 1 mole of carbon dioxide plus 2 moles of water. That is 16 grams of methane reacts with the 64 grams of oxygen. It gives 44 grams of carbon dioxide and 36 grams of water. So in order to produce 44 grams of carbon dioxide, it required 16 grams of methane and 64 grams of oxygen, right? For example, if you take that is 16 grams of methane and 32 grams of oxygen, so it does not produces 44 grams of carbon dioxide, because in order to produce 44 grams of carbon dioxide, the reactant's required amount is 16 grams of methane and 64 grams of oxygen, but we have 32 grams of oxygen. In that case, it does not produces 44 grams of carbon dioxide. So the reagent which is present in lesser amount and gets consumed after some times, it is to be called as limiting reagent. That is, limiting reagent is the reagent which is completely consumed during the reaction, or to be called as limiting reagent. The reactant other than the limiting reagent, which is in somewhat excess, is to be called as excess reagent. So it is to be called as excess reagent, and this oxygen is to be called as limiting reagent. Limiting reagent. Why it is to be called as limiting reagent? Because it has less amount in the chemical reaction. So the reagent which is present in the less quantity, readily it is to be consumed and it is to be converted into product. So the reagent which is consumed during the chemical reaction, that is completely consumed during the chemical reaction, such reactants are generally to be called as limiting reagents. Let us see the stoichiometric calculations in the chemical equations. That is, first one, calculate the amount of water produced by the combustion of 16 grams of methane. These examples are very important for the competitive exams. Let us see how to solve this problem. So what we have to calculate? So we have to calculate what is the amount of water produced by the combustion of 16 grams of methane. First, let us take the combustion reaction. That is combustion reaction of methane. So the combustion reaction of methane is CH4 reacts with the oxygen and it produces carbon dioxide plus water. So the number of moles of methane is 1 mole and oxygen is 2 moles and water is also 2 moles. So it is a balanced chemical reaction. So in the balanced chemical reaction, let us calculate the mass of the reactants and products. So here there is an 1 mole of methane and 2 moles of oxygen and 1 mole of carbon dioxide and 2 moles of water. So mass of 1 mole of methane is 16 grams and mass of 1 mole of oxygen is 32 grams. So 32 into 2, that is equal to 64 grams. And molecular mass of 1 mole of carbon dioxide is 44 grams. And for water molecules, it is 2 into 18, that is equal to 36 grams. So when 16 grams of methane reacts with the 64 grams of oxygen, it produces 36 grams of water. So in the question they have asked about the how much amount of water in grams produced by the combustion of 16 grams of methane. Therefore 16 grams of methane reacts with 64 grams of oxygen produces 36 grams of water. So in order to produce 36 grams of water, we have to take 16 grams of methane and 64 grams of oxygen. Let us see one more problem, that is how many moles of methane are required to produce 22 grams of carbon dioxide after combustion. How many moles of methane are required to produce 22 grams of carbon dioxide after combustion. So the reactant is methane and the reaction is combustion reaction. That is, first write the balanced chemical reaction, that is methane reacts with the oxygen gas and it produces 1 mole of carbon dioxide and 2 moles of water molecules. So we have to convert this number of moles into masses, right? So 1 mole of methane reacts with the 2 moles of oxygen and it produces 1 mole of carbon dioxide and 2 moles of water. That is 1 mole mass is 16 grams and 2 moles of oxygen is 64 grams and 1 mole of carbon dioxide is 44 grams and it is 36 grams. So in the question they have asked about the methane and carbon dioxide. So select methane and carbon dioxide. So 16 grams of methane produces 44 grams of carbon dioxide. So how much amount of methane, that is how many moles of methane required to produce 22 grams of carbon dioxide. So in the question it has 22 grams of carbon dioxide, right? So it is standard statement 44. So we have to convert how many moles of methane are required to produce 22 grams of carbon dioxide, right? First let us convert this mass into number of moles, that is moles of carbon dioxide is equal to mass of CO2 divided by molar mass of CO2. That is mass of CO2 is 22 grams divided by molecular mass of carbon dioxide is 44 grams, that is equal to 0.5 moles, right? That is 0.5 moles of carbon dioxide. So in order to produce 0.5 moles of carbon dioxide, it requires 0.5 moles of methane. So we don't want the 1 mole of methane, right? So if we take 1 mole of methane with the 64 grams of oxygen or 2 moles of oxygen, it produces 1 mole of carbon dioxide. So mass of 1 mole of carbon dioxide is 44 grams. So but in the question they have to ask about the how many moles of methane required to produce 22 grams of carbon dioxide. That is 0.5 moles of methane would be required to produce 22 grams of carbon dioxide. So in order to produce 22 grams of carbon dioxide, we have to take just 0.5 moles of methane. So 1 mole of methane produces 44 grams. So 0.5 moles of methane produces 22 grams of carbon dioxide.